Welcome to 1.2, page 2. Here we're talking about functions in this section, and we'll pick it right up at number 20, where we're going to determine if the equation represents a function y, or represents y as a function of x, which means we're putting x in to a factory and we're getting y out. So I want to solve these equations for y. Now, I would say this: if we knew what the graphs of these look like, the graphs can tell the whole picture for us, because there's what's called a vertical line test, which we're going to look at more, where if I have a graph, let's say it looks like this, if a vertical line, any vertical line only hits at most one point on the graph, it is a function. Whereas if I have a graph that looks like, let's say, that, a vertical line hits 2 points on there. One of the big emphases this semester will be you'll be able to look at perhaps every equation like this and determine if it's a function or not. But we're going to work under the assumption that you don't know, what the graph of let's say this looks like, and therefore we're going to go algebraically rather than graphically on this. And what we want to do is solve for y. So I have y squared equals, let's see, it was x, and I need to subtract away 1. Now, if I said x squared equals 16, and I asked you, well, what does x equal? I suspect some people would get this right, and I suspect some people would say, oh, x equals 4. But x doesn't just equal 4. To rescue a squared, we actually have to go x equals plus or minus square root of 16. So x is plus or minus 4. So that means this would be y is plus or minus square root of x minus 1. And that's very revealing right here, because that means when I put, let's say I put 5 in for x. When I put 5 in for x, I get y equals plus or minus the square root of 4. I get y equals plus or minus 2. That means that 1, 2, 3, 4, 5 in for x would give me a point here, a point there, and we've got some elf confusion right there. So this is not a function. Now, not to get confused with this one where there's already a square root in, you don't put the plus or minus in front of this, it's already a square root that exists. To rescue a squared, we have to use plus or minus square root. So this is already solved for y. There is no plus or minus. No matter what value I put in for x, I only get one value out. In this case, when I put in 4 or 5, I get 2 different values out. My elf in charge of 5 has been told to make them be 2 different things. Here, when I put in 0 for x, or -5 for x, or 10 for x, I get a different value. So if you can solve for y without introducing that plus or minus, with where we're at right now, pretty safe assumption, it is a function. So likewise, we get down to 26, solving for y squared. For y, I get y squared equals 3 minus x. Y equals, there's the magic, plus or minus square root of 3 minus x. Not a function. And here's an absolute value. You should be familiar with that. If I had absolute value of x equals 7, and I ask, what's the solution to that? What value can x be? I suspect some people say, well, if x is 7, it's true. But also if x is plus or minus 7, positive or negative 7 in there would make this statement true. Therefore, to solve for y here, I rescue absolute value with plus or minus of the quantity. And that means if I put 10 in here for x, I'm eventually going to get 2 different answers. So this is not a function. And just as before I've been talking about this, when you get a plain old x equals or a plain old y equals, you ought to just go to the graph. So is it out here, or is it up there? Because this is most definitely not a function. I mean, there couldn't be a more confused elf in the world than the elf in charge of 8s that's just been told, you take that 8 and you turn it into anything you want it to be. But this one is a function. Well, this y is a height. Y isn't up or down. This says all the points are up 8. So our graph is right here. And tell me about this factory that we have. This is a factory that's producing 8s no matter what we put into it for x. So this is a function. Okay. Now we have some defined functions below this, and in this section we're to evaluate the function at the specified value of the independent variable. So when I teach Algebra 1, people who haven't seen functions before, we take a full day and I just have a big worksheet of things that look like this, and I have them write out in words virtually exactly like this. They would say, well, G is a factory that takes things, multiplies them by 3, makes that negative, and then adds 7. G is a factory that takes that thing and puts it right there. So G is going to take 0. 0 was driven into that factory. 0 goes right here. So we get 7 minus 3 times 0. 7 minus 0, 7. 7/3 is driven into that factory. We get 7 minus 3 times 7/3. That's 7 minus 3's cancel. 7, 0. And then s plus 5 is driven into it. The whole s plus 5 is the thing. And this is a factory that takes things and puts them right there. So this is 7 minus 3 times s plus 5. But right there I've just made the common mistake. Besides, my s and 5 look exactly alike. The 3 is being multiplied by the thing, and the thing is s plus 5. The s plus 5 takes the place of y. So this should look like that. And we're still not out of the woods, because the most common algebra mistake is staring at us. We're going to get minus 3s, and then minus times plus. That's the most common algebra mistake. Minus 15, so we end up with negative 8 minus 3s, or negative 3s minus 8. Okay, 36. X is a factory that takes things, adds them to 8, takes the square root of it, and then adds 2. But X is a factory that takes things and puts them right exactly here. So for A, we get square root negative 4 plus 8 plus 2. That's square root of 4 plus 2, 2 plus 2, or 4. Put in 8. Square root 8 plus 8, then plus 2. 16, square root of 16, not 14, wow. Square root of 16, 4 plus 2, 6. And negative 8, square root of 8, square root of negative 8, plus 8 plus 2 is square root of 0 plus 2, or just 2. And then I've been led to believe that maybe this isn't being taught in our lower level courses, our courses that, not that they're low level, but the courses that lead up to this. This is what's called a piecewise function. And basically what we have here is a factory that inside the factory they do 3 different things depending on what the value of x is. Like if I call this A, B, C. So in my mind I'm seeing the elves have a little chute here for handling A, and a little chute here for handling condition B, and a little chute here for handling condition C, depending on the value of x. So if -4 goes into F, we check this condition. -4 is less than 0. It's not between 0 and 1, and it's not bigger than 1. It gets this treatment. So this gets treated with A. That's not intended to coincide with this, but they just might coincide. So I get 5 minus 2 times -4, or 5 plus 8, 13. F of 0. We send 0 in here, and I've got this little elf sentry out here that says, hey, ship this down to here, ship this down to here, ship this down to here. 0 is not less than 0, but 0 is less than or equal to 0, and that's less than 1. This gets treatment B. And treatment B is a factory that just makes 5s. It's not 5 times the 0, it's not 5 plus the 0, it just turns things into 5s. And then 1 almost qualifies for 0 is less than or equal to x is less than 1, but it's not. 1 is greater than or equal to 1, so C does get a treatment C. That was purely coincidental that I did that. So that is 4 times the thing that came in, 1, plus 1, or 5. So there you have it, not too bad a page. And again, we're just going to try to take a page of the notes. Your notes should look like this, and the work that you do should resemble what we just did there. I'm not really interested in just seeing on 36 the solutions to this. I want to see, or on 37, not interested in just seeing the solutions. Interested in seeing the setup. I need to be convinced that you can do that, and I totally believe you can do this in your head. Sure, we all could. F of 2, put in 2, we get 6 plus 1, 7. Set the problem up. You need to convince me at this time that you can follow the process. So thanks a lot. Ask questions, and we'll talk with you soon.